in New York. Let me give you a little bit of background on me so that you know where I'm coming from. So I started my journey in data science more than 20 years ago when I was starting out in undergrad. I had a passion to make the world a better place. I started in a genetics lab. My parents were disabled, and so I was building computational models at a very early age during the genome race in the late 90s and early 2000s on decision systems that would make it possible for people to have micro-targeting of ameliorative states through specific location of genome micro-targeting. Let's just call it that. And so that's what I did my thesis on, that's what I did my work in, and never did I expect in a million years that we'd be where we are with this big boom of AI and what it's called today. So in the last 12, 14 years, for the first 12 years of my career, maybe 10 years of my career, most of what I saw was a data science function as write a SQL report up, pull out such and such an abstract, can you analyze this data, build a macro for me, go build a database, sort of the classic nuts and bolts of what still is the heart and soul of analytics and AI. To this day still, that's what AI ultimately means. Find where all the data repositories live and lie. So there's no mystery behind where this data, magical data assets are. We all see them everywhere, every day, all the time. What has changed, however, and we'll get into that, is where the compute power is taking us and where the capabilities are taking us and where we're seeing deployments of these algorithms and capabilities. That's the magical part, where analytics, AI, and all of these systems are going. Okay. So very quickly, I don't agree with this definition 100%, but artificial intelligence is machine intelligence. And I want to be very explicit in machine definition of this. So it's intelligence exhibited by machines rather than humans or other animals, which is called decontextualized intelligence. Intelligence in this sense means taking unstructured information, structuring it, and using it for a larger purpose. I want to talk a little bit about very, very quickly about what this whole profession of data AI actually consists of. So I mentioned to you I'm a data scientist. There's many people who are data scientists out in the world these days. Most of us come from a variety of different fields, but most of them know and work actively in these fields. So you often hear these buzzwords, big data, where you'll see like Hadoop, NoSQL database architectures deployed, you'll see that. Deep learning is a subset of a much larger data mining activity in machine learning and deep learning. It's a type of data architecture. I'll get into that in a minute. Above that, you'll see the four, if you will, windows into how the data actually behaves. So business analytics on your left, business intelligence, statistics, and data visualization. Those are four ways that data is accessed and utilized. And then machine learning and data mining and predictive analytics, that's how the machines use their own data repositories for themselves. The neural networks on the back are, if you will, the gearboxes on how the data systems talk to each other. And AI is, if you will, the rear propeller, the rear wheels that kind of push the engine forward. So this is kind of my rudimentary makeshift bus, the little bus that, where the wheels turn, the wheels on the bus go round and round. I say that a lot to my 1-year-old, so maybe that's why it's there. But this is my little AI, data engineering, data science bus. So again, at the top is data science, the actual profession of data science at the math level. At the bottom is the data engineering. So those are the folks that are actually working on the plumbing systems that put together AI solutions. Okay. A very quick history of AI. We covered this a little bit on Monday. There was a workshop on it. But AI as a profession and as a thought idea has been around for a long time. So since the 60s, the idea was proposed that we might be able to use machines to simplify decision making on the whole. And so since the 60s, the idea of modeling neurological processes that you see in the human or animal brains have been modeled. And when you see neural networks, that's the term for them, of how a data stream behaves, it's known as a neural network. The propagation layer is the back propagation. These are all technologies that have been developed from the 60s until the 2000s. So all old technologies, we've all seen them, we've all even used them or touched them. What has changed recently is this tremendous ability for us to build vast assets of data from everywhere all the time in many ways. Machines propagating data, humans propagating data, data systems propagating data. They say in one day, humanity generates more data than all data that was written or spoken ever from the dawn of humankind to the year 1900. In one day, every day. And every day that's exponential. Every day. Most of it we don't even see or touch. That's when we need help. So this is another visualization of how this whole world of AI works, and to simplify it. So you'll see traditional analytics at the top, but basically you can see 4 kinds of workloads broken down inside that, which is the sensing portion of it. So you'll often see sensors, for example, your Roomba at home, when it's avoiding touching a certain wall or plant, that's a sensing system. That's not an intelligent system, but one can argue that that's an AI-based rudimentary algorithm that's being built in through the sensors to interpolate into the processor to avoid that. The reasoning part is actually autonomously making a decision to avoid that. So imagine your Roomba gets smarter maybe 2 years from now and actually develops a pattern and says, I'm going to avoid that piece of it. But again, there's no cognition, there's no real intelligence. It's reasoning its way around a problem. Okay. And then acting and reasoning usually go hand in hand, and adaptation is the next layer. All of those 4 workload at the top of the layer are powered by the 4 bottom layers, which are the deep learning, classical machine learning, memory-based systems, and logic-based, rule-based systems on the top of them. And they feed into this propagation layers called machine learning and reasoning. Most of us have seen these. Again, so George, I think you were telling me about the systems that you've built. Those are largely reasoning-based and logic-based systems. So you've already been in the field of AI in your own way. It's just at a new level of complexity, I think. So all of us have actually seen all of this. So again, don't get frightened and scared of this. Ultimately, let's see, why is it not advancing? Is it, okay, there we go. Ultimately, it breaks down into 2 things. Are you designing your system to do many tasks well, or are you designing it and optimizing it to do a few tasks well? In your mind, I want you to think, do a quick thought exercise with me for about 10 seconds. Don't look at any slides, don't look at your neighbor. Just quietly close your minds just for 5 or 10 seconds and close your eyes. And in your mind, imagine a mine where you're mining metals. And in this mine, you have a giant drill bit that's going deep into the core of the earth, and you're harvesting vast chunks of rock and stone, but also ore. Then imagine all of these vast conveyor belts that are sorting out these rocks and sifting them into densities. You see trucks moving all over the place. You see different sifting and sorting systems. Think of that in a vast, large scoped way, and then at the very end, you're seeing tiny little ingots of metal coming out. Your gold, your aluminum, your steel. Now open your eyes. So when you're looking at this tiny little ingot of gold or aluminum or steel, and you're looking at the 50 tons of rock that this tiny 2 pounds of steel emerged from, that is what an AI system can do. It can differentiate between the steel and the 50 tons of rock that you just drew out. And it can sort through what is useful or not, because guess what? In that rock, there's many other assets you're going to use again. Hence, when you're looking at many different tasks that you need to do, that's how you design an AI system well. Okay? I'm going to go very quickly over, stop talking about the technical stuff and go into where information is headed and about how and why empathy is a big part of this. Any questions so far at a high level? No? You guys good with it? Okay, good. I haven't scared anybody. So we talked a little bit about the information Big Bang, but remember, every day we generate more data than the beginning of humankind up till basically yesterday. Every day, every freaking day. I use the X, sorry, I'm a New Yorker, we talk that way. But yeah, that's pretty mind-boggling. When the steam engine and the Industrial Revolution came out, there was a tremendous amount of fear. And from 1700 to 1825, it took a long time for the actual railway systems to be put in before the steam engine was found and for that automation there to be put in. Similarly, it took a long time from the time we first discovered AI systems to the time we're actually going to be putting in. So we hear a lot about the fear around we're going to lose jobs, and we're going to lose humanity, and we're going to lose emotions, and we're going to, all of this stuff. But there was also, and is a tremendous amount of data, that we actually gained more human advancement out of the Industrial Revolution than actually we lost. Apparently, humanity, if you look at the metrics, depending upon how, we gained 20 to 200 times more economic and life value in 2 generations, just 2 generations after the steam engine was introduced. One of the arguments about why and how right now we're heading into the world of AI, and especially those of us who are at the edge, who are working on payment systems, sensing systems that are at the very edge and touching consumers, touching users, is that we have the ability to interface with and impact directly how people, how consumers are actually interacting with their minds, with their emotions, and with the world at large in a very intimate and material way. We're effectively touching where their synapses are actually interacting with their brain. Every time they touch a product of ours, it's literally going into their brain, and that brain is actually feeding all of the data system in a very real time way. Our brains, just like any other AI system, also acquires data and calculates algorithms. We also propagate data. This system, if you have never seen this image before, this is this very, very simplified one, but I want to share this with you, and then I want to talk about where and how AI, I believe, is headed. This is probably the most important slide. This image is known as the homunculus. This is a infographic map of where our brain, so if you look at the left image right there, that's an image of the brain, and that middle cortical layer is where most of the processing for sensory and cortical stimulation processing is. You might say that's where the convolutional neural network interpolation happens. So the front side of your brain takes in the data, just as all of our payment systems take in all the data. Collecting the data is one piece of it, but aggregation of that data stack and translating it into sensing systems is another thing, right? So this is how the brain actually maps. If you take the brain map to where the sensory outlay is, our hands, our lips, our mouth, our, to some extent, this image doesn't depict it perfectly, but our toes, our eyes, our ears, basically our sense organs are the largest disproportionate sensors for our brain. There's many theorists who argue that AI systems, when they're being developed, right now if you look at AI workloads, most of them are around image processing, language processing, data processing, sensory processing. That's it. That's what 99.99% of all compute workloads right now in the AI world look like. I believe, especially for all of us, again, whether you're in healthcare or whether you're in payment systems, but especially for those of us who are in payment systems, the systems that we're all going to be touching are going to have to talk to the human empath. So if you have a payment system, you might soon, in the next 3, 4, 5 years, be bringing out cards or products that have a warm, fuzzy texture because it stimulates the hands, which means it gets them to swipe more, or touch more, or scan more, or interact more. The things that engage these stimuli and these senses are the ones that are going to be mapping back to other users and also the AI systems that are in the back end that are processing this data. Data is propagated by other systems that consume the same assets, that also build the same assets. That's usually what you see, this magical trifecta in the AI knowledge processing world. I'm going to pause after 2 slides because I'm being given the time mark. Effectively, this is just simple physics, the number of transistors that are going to exceed processing in the brain by 2020, that's the latest number. But essentially, the brain is going to be outpaced by a chip in about 2 to 3 more years in terms of the number of overall circuits. However, the ability to connect the sensory workloads and the emotional part still belongs to us. Remember in the very beginning part, I said that the human feeling part, the ability to disaggregate workloads and then compile them back together is something that's uniquely human right now and will continue to be very uniquely human. And the feeling part, what Dalai Lama said, that part is going to be very proprietary. And that will be proprietary to every individual. And that is going to be where I think monetization algorithms, monetization systems, all of our products and technologies are slowly but surely going to be marching towards. And the way you march towards that is where the sensory systems are going to start climbing towards, and where the emotional systems will start climbing towards. I have a